Hi, everybody. Today we're looking at solving a system of equations by graphing with word problems. This is U3 from IXL, so let's get started. And our first scenario says Aunt Anne is pricing cakes for a baby shower she is throwing. She wants one cake shaped like a duckling, and also some cupcakes in pastel colors. Newton Bakery charges $2 for each cupcake and $4 for the large cake. Karen's Sweet Shop charges $30 for the large cake and $4 for each cupcake. If Anne orders a certain number of cupcakes, the cost will be the same at either bakery. What will that cost be? Clearly, she wants to see where the break-even point is, where one is the same as the other. So this is a very common thing in some of you have had a business class or something, and it's looking at the point at which each of them are equivalent, and then you can look at other ideas. Anyway, you can look at other characteristics of the business. So we have Newton's Bakery charges $2 for each cupcake. And I could put C for cupcake, but there's a cost too. So I'm just going to use X plus the $40 for the one cake. Because Aunt Anne's only going to get one cake, it's going to cost her the $40 plus the $2 for each cupcake. Now, Karen's Sweet Shop charges $4 for each cupcake and only $30 for the large cake. And so we need to graph both of these. Now, the problem that we run into is with scale. This scale is small, and this is counting by fives. So what's going on is that each one of these units counts 5, and each one of these units only counts, each of these X units counts 1, while the cost counts 5. This has the effect of compressing your graph, and it looks wrong. It's not going to look like 2x plus 40, because I can't go to 40 and then just count up 2 and over 1. It doesn't work that way. And I can't go to 30 and count up 4 and over 1. What we have to do is change these to fifths so that it'll be a power of 10. And we do that by multiplying our slope by 5 over 5. So I can't remember what the n stood for. Nancy, I think. So Nancy's charges $2 for one cupcake, which is the same as charging $10 for 5 cupcakes. Now this slope I can count. So I can start at 40 for Nancy, and I can go up 10 over 5, because 5 cupcakes cost $10. Now Karen starts at 30, and notice I have to change the color. Karen starts at $30, but she charges 4 over 1, which is the same as $20 for 5 cupcakes. So if I go up $20 for 5 cupcakes, I'll be here. And they are both equivalent at 5 cupcakes for $50 and a large cake. And the dollars is the one that they wanted for the solution set, and it's going to cost $50 at either one if they buy 5 cupcakes. That's our break-even point. Clearly, the reason that that point's so important is that below that, if you buy fewer than 5 cupcakes, then it's better to go with the green one. And if you do more than 5 cupcakes, it's better to go with the blue one. And I suspect that Newton's Bakery is going to get Aunt Anne's business. All right, Bernard is kickboxing instructor who will be teaching classes at a local gym. To get certified as an instructor, he spent a total of $150. Bernard will be earning a base salary of $100 per month from the gym, plus an additional $5 for every class he teaches. If Bernard teaches a certain number of classes during his first month as an instructor, he will earn back the amount he spends on the certificate. How many classes will that take? Write a system of equations, graph them, and type the solution. So This is an earnings versus expenses situation. And again, this is a very common kind of graph that you want to analyze in business. And I'm going to go ahead and start. Let me get rid of this for a second so I can move back and forth. So his expenses are $150, aren't they? And his earnings are going to be 100 plus the 5 per class. So expenses was the cost, the expenses. And the problem with this is I can't use E for both. So I'm going to go ahead and just put Y1 is the expenses, and that's going to be 150. And my second equation is the earnings. That's going to be Y1 and Y2, and that's going to be 100 plus $5 per class. Notice that I used C instead of X. I guess I could have used X. It doesn't matter. Now, at 150 is our expenses. So the 150 looks like this. This is the level at which he spent his money. And he starts at 100 for the earnings. He starts at 100 and he earns $5 for each class. Now, I can't just go up 5 and over 1 because these are counting by 50s, aren't they? This is 50, 100, 150, 200. So 5 over 1 class is the same as $50 for 10 classes, isn't it? So on the orange one for the earnings, I'm going to start at 100 and then it's going to go up $50 for every 10 classes. And that is the solution. Don't know. I better not write on it because then it'll think I'm changing the points. So anyway, for 10 classes, he's going to earn the $150. And of course, it's not that hard to see that that's the solution, but they wanted specifically for you to graph the situation because sometimes it's not that easy to see. So he's going to have to do 10 classes to earn back his cost. Okay, so they're comparing international calling plans. Miranda pays $1 to place a call. That's the initial charge. Now this is usually the y-intercept. We usually write it on the other side, but it'll be fine. And $2 for each minute that she calls. I'm going to go ahead and use X instead of M since I used M for Miranda. Jen pays $4 to place a call and $1 per minute. So here's the two equations that we have to graph. Miranda's is in purple or blue if you like. It's 1. The cost is $1 plus $2 for each minute. Now this time we actually do get to count the slope because it went up $2 for every minute it goes by. When the scale is the same, it makes it a lot easier to graph. Now we have Jen, which is at $4, but her cost, oh shoot, I didn't change it. Sorry. That's 2 over 1. Then we go to Jen. Jen's initial cost is $4, but it only goes up $1 for each minute that goes by. And of course, we can see on the graph that their equal point is at 3-minute calls, which cost $7. Pretty expensive. And so it's going to happen at 3 minutes, isn't it? And you can see in here that $3 for Miranda's cost $7 and $3 minutes for Jen cost $7. So you can check your answer as you go. All right, Estelle's going to ship some gifts for family members, and she's considering 2 shipping companies. The first shipping company charges a fee of $20 to ship a medium box, plus an additional $1 per pound. So the cost for Estelle, let's go ahead and write E for Estelle, is going to be 20 for a medium box plus $1 per pound. Again, this is our slope. This is how much it's increasing for X pounds. The second shipping company, this is Estelle 1. So shipping company 1 and shipping company 2. I'll just call it E1 and E2. Charges $10, but they charge $2 for each pound. So these are our 2 equations that we want to consider. And we're looking for the point at which the weight is equivalent. And the reason for doing that is that that's the change point, isn't it? Where you go from one shipping company to the other. Let's go ahead and take a look. The first company is 20 plus 1x. Now, the bad news is that this is, almost the same scale, but they're just a little bit off, aren't they? Take a look. This one is counting by fives for the weight, but they're counting by tens for the cost. Scale really matters because the first shipping company is a slope of 1, which is $1 for every 1 pound. But the weights are being counted by 5. So that is the same as $5 for 5 pounds. I could also use the $10 for 10 pounds. Either one will work. Either way, I'm talking about a slope of 1. Hopefully that's clear. And for the blue first company, I am going to increase 5 over 5, which is hard to do because there's no points on that one, so that one's not going to work. I'm going to use the 10 over 10. So it goes up 10 for every 10 pounds it weighs. So the next one is going to start at $10, and it's going to go up $20 for every 10 pounds, isn't it? So it goes up $20 for every 10 pounds. And there's the two equations. And let's see. And the amount of money, they're both going to charge $30 for a 10-pound package. And if I put the 10 in here, I can see it's 30. And if I put the 10 in here, I can see it's 30. So it's going to cost $30 for 10 pounds. I probably should have checked the question to see if they were actually asking for something else. But chances are very good that they're asking for the set point, but I should have read the directions. Janelle, an office manager, needs to find a courier to deliver a package. The first courier, so I'm going to call it C1. So first courier charges 20 plus $2 per kilo. I could use K for kilo. The second one, the second courier, charges $5 plus $3 per kilo. So there's my two equations. Let's go ahead and move it up. Look out for your scale. Beautiful. Our scale is 1-to-1. Notice that the 10 and the 10 match up, and the 20 and the 20, and so on. So we're going by 5 kilogram intervals, and we're going by $5 intervals. The first courier, we're going to be able to count the slope. Oops, I don't need this. The first courier is going to be 20 plus $2 for each kilo, which is 2 for each kilo, like this. The reason I'm allowed to count is because they're the same scale, but it's probably better to explain what happened. So it costs $2 for each kilo is the same as $20 for 10 kilos, isn't it? Well, it's a good thing I checked. How did I mess it up? They're not the same scale. Yeah, they are. Oh, dummy. I counted 2 over 5, but it's the same as, because I went up 10 over 5, so I was doing 10 over 5, so it's okay. 10 over 5 does work. $10 for 5 kilos is the same. So I went up $10 for 5 kilos. That's all right. Now the other one is going to start at 5. So it's going to start at the $5 mark. This is the second courier. It's here. And it's going to go up 3 over 1, which is here. And up 3 over 1 is the same as up 15 over 5, isn't it? Which is that point right there. Now let's take a look and see where our intersection point is at 1550. 15 kilos costs $50. And in this first equation, the first courier we can see costs 50, and the second courier is 45 plus 5 makes 50. It is really, really easy to make a mistake when you have different scales. But when the scales are the same, you can literally count the slope by using the points or the marks on your graph. Makes it much easier. And the same dollar amount is the 50. I'm going to double check my question and make sure I'm actually answering it. The equivalent in cost, how much will it cost? And the equivalent cost was $50, wasn't it? I suspect a lot of people have trouble with the scale on this. All right, let's take a look since I did. I don't know, maybe not. Do that for a second so I can move it. Okay, so Ruth and Erica both plan to run for a spot on the school board. So far, Ruth has 30 signatures, but Erica hasn't started yet. Ruth is collecting signatures at an average rate of $6 per hour, 6 signatures per hour, while Erica can get 9 signatures every hour. Assuming that their rate of collection stays the same, which is a big assumption for linear, eventually the two will have collected the same number of signatures. How many hours will have gone by? So Ruth, come on, Ruth has 30, but only collects 6 signatures per hour. I don't have to use R and H. I could use Y and X. It's the reason I like to use variables that have something to do with the problem is that it keeps you from making errors as far as identifying which is which. All right, so then Erica hasn't started, but she gets 9 per hour. So Erica has 0 right now, but is collecting 9 per hour. Now these are written backwards. Of course, usually we write mx plus b instead of b plus mx, but it doesn't matter. All right, so let's graph Ruth, who is at 30 signatures right now. Our scale is not the same. That means that you cannot go up 6 over 1. It doesn't work. You're going to have to change it so that the larger scale, which is the 10, will work out. The way to do that for Ruth, since Ruth has 6 signatures per hour, we can multiply by 5 on the top and the bottom and get 30 over 5 hours. So Ruth will collect 30 signatures in 5 hours, which is the same as 6 over 1. 30 is 10, 20, 30 over a period of 5 hours. Be very careful of counting these. Be careful in counting those. Notice that that looks like a slope of 3, but it's actually a slope of 6. The reason is that the scale in the y values is double the scale in the x values. These x's are counting, or the hours are counting by 5s, and the signatures are counting by 10. Hopefully all that's clear and it'll help you be able to do it yourself. Now Erica's going to start at 0 signatures, and then she's going to collect 9 per hour. Now 9 is the same, 9 over 1 is the same as 45 over 5. But the problem is that this 45 gives us trouble, doesn't it? So I have to do 90 over 10. So 90 over 10 will put me right there, won't it? Oh, 90 over 10, sorry, there it is. You got to read it carefully. I guess I could have done 45. Yeah, I could have gone, no, I couldn't do 45 over 5. I had to do the 90 over 10. And then it's a number of hours, which is the 10 hours. Make sure that you get, after 10 hours, they both have 90, and they do. That's how you can check your answer. And it really doesn't take very long, okay? Sorry, I keep looking down instead of looking at you. There you go. So let's try another one. Let's see how this one goes. Sorry, guys, I haven't been looking up much. It says, Becky is comparing the cost of a fresh lobster dinner, at 2 different restaurants. The first restaurant charges $30 for the meal, plus $3 per kilogram. I don't think so. It's going to be more like about $3 per gram, but okay. $3 per kilo for the lobster she picks. At the second restaurant, she pays $4 per kilogram for the lobster, in addition to the $20 for the meal. I'll tell you, I want to eat there at $3 and $2 a kilogram for lobster. I definitely like that cost. So they really don't give me a name. So I'm going to use R1 and R2. So the first restaurant is going to be my R1. And of course, they're charging $30 plus the strange $3 per kilo. I suspect that it would be more like $3 per ounce, really. That's actually reasonable. 20, the restaurant 2 is $20 plus the $4 per kilo. So again, I didn't have to use K. I could have used X, could use whatever variables you like. Again, I could call restaurant 1 and restaurant 2 something else. I just thought it would be easier to keep track of them this way. So my first restaurant is at $30 to start. There's 30. And I do not have the same scale, so I need to be a little bit careful. $3 per kilo is the same as 30 over 10. So on my first restaurant, I'm going to go up 30. That's 10, 20, 30 over 10. You need to make sure that you go over 10 and not over 5. It's really easy to make that mistake. I've done it before. All right, so the second restaurant, we've got $4 per kilo, which is the same as 20 over 5, which we could do. I can do 20 over 5, so I think I'm going to go ahead and use that. And we start at 20. And it goes up 20 over 5 and 20 over 5 and so on. And at 10 kilos, they both cost $60. Wow, beautiful. That would be a nice lobster. A 10-kilo lobster is a monster. So that's going to cost 60 and 60, sure enough. You can tell I get distracted with the lobster idea. 10 kilos is going to be the break-even point, isn't it? Yeah. Beautiful 20-pound lobster. Yeah. I'll go for that. All right. Sebastian and Gary are racing to see who can get his community service hours for scouting completed first. Yeah, scouting. Okay. Sebastian, who has already completed 20 hours, volunteered for 6 hours per week going forward. So Sebastian has, yeah, they make it a nice thing. Scouting's okay, I guess. Sebastian has already completed 20 hours and he's going to volunteer for 6 hours per week. I'm going to use W for that. That way it's number of weeks going by and I'll know how many hours he's completed. Gary hasn't started yet, but plans to dedicate 10 hours per week, which would be this one. So there we go. I'm not going to go into the details too much. Just check my scale, which is definitely not the same. So I do have to be careful with my scale. Let's start with Sebastian, who's the blue one. And we're going to start with his 20 hours. There's his 20 hours. And he's going to go up 6 hours every week. Notice that a 6 over 1 is the same as, let's go ahead and go with 30 over 5. He should complete 30 more hours over a period of 5 weeks. Now, it's really easy to make a mistake on this, so just be careful when you're counting your slope, that you're actually counting what you think you are. So let's go ahead and move this down. There we go. So from the 20 hours that Gary starts with, he's going to go up 30, 10, 20, 30. Unfortunately, these are counting by 5s. That's not going to work. It would work, but it's actually, yeah, let's go ahead and go with that. So up 30 is actually going to put me at 50, isn't it? You see how you can make a mistake here. It's really easy to miscount. So he's at 50 over a period of 5 weeks, which puts him right there. There he is. Now Gary is starting, make sure I have the right one. Yep, Gary's in yellow or orange. He's starting at 0, and he's going to do 10 for each week that goes by. Now this one is much easier to do because 10 over 1 is right there, isn't it? And let's see if they intersect. And the intersection appears to be at 5 weeks. They should both have completed 50 hours. And sure enough, that's the break-even point. So that's a race to the 5 weeks. And it is going to be how many hours, though? Not 5 weeks, but 50 hours. Got to make sure you get the right units in there. Okay, guys. Antonio has punch cards for his favorite tea house and his favorite coffee shop. He currently has 3 punches on the tea punch card and 7 on the coffee punch card. Given his regular routine, he consistently earns 3 new punches per week on the tea and only 1 on the coffee. Antonio will have the same number of punches on each card. How many punches will he have on each card? Okay, so they want the break-even point for it. We've got coffee and tea, so I'm going to use C and T. So I'm going to use T for the tea punch card and C for the coffee punch card. And he currently has 3 on the tea and 7 on the coffee. That's his initial points. This is the y-intercept. And on the tea, he's going to earn 3 new punches each week. And on the coffee, he's going to earn 1 new punch each week. So there we go. We want to know when they're going to be equal. At the tea house, he's going to start with 3. There's 3. And he's going to earn 3 per week. Oh, very nice. They have the same scale. So I can literally go up 3 over 1. That means that he's going to earn 1, 2, 3 more punches for 1 week. At the coffee house, he starts with 7. Oh, dang it. Gotta get rid of that. There we go. He starts with 3 and earns 3 per week. There we go. Then I have to change to the coffee. Now I'm going to do 7 and 1 per week. And it looks like their break-even point is at 2 weeks. And let's test it. Put 2 in here and 2 in here, and they should be the same. 9 and 9, sure enough. So I'll have 9 in each of the punch cards after 2 weeks. We're getting there. These do take a little while because you have to read them, you have to interpret them, yada, yada, yada. Oh, nice. Gina's training for a triathlon and needs to swim a certain distance for today's workout. If she swims at the rec center, she will complete a 250-yard warm-up and then swim laps in a lane that is 15 yards long. If Gina swims at the indoor pool at her gym, she will complete a 200-yard warm-up plus a main set that consists of 20 yards per lap. If Gina swims the correct number of laps, she can complete the same distance in either pool. How many laps will that take? So yeah, she wants them to be the same. That kind of makes sense. Swimming at a 15-yard pool is really kind of irritating. You only get in a couple of strokes, but here we go. So we have rec center. So it's rec center and we'll say gym. So we'll use R and G for me. I'm going to use R for the rec center and G for the gym. And at the rec center, the gym was 200 plus 20 yards per lap. I'll use L for laps, why not? Let's use a capital L there. And the rec center has 250 warm up plus 15 yards per lap. So there's our 2 equations. We want to be able to write them. Let's see how the scale works on here. It looks like we can definitely put the 250 in, and we can't count by 15. This 15 needs to be changed to 150, doesn't it? So that's 150 over 10 laps. That's the same as 15 yards per lap. So 150 over 10, I'm going to start with the rec center at 250, and then it's going to go up 150 over 10 laps. Then for the gym, she's going to start at 200, and she's going to get 20 yards per lap, which is the same as 100 over 5, which I can put on this graph. So I can go from here up 100 over 5. And it looks like her break-even point is at 10 laps. She's going to have completed 400 yards, which is not very much for a triathlon. Triathlons generally run a 2 or 3 mile swim, which you're talking about 10, 20,000 yards. Anyway, so the laps, the break even at 10 laps, 400 yards. And you can put them in and see that at 10 laps, they both equal 400. So it's always good to check your answer. All right, Hakeem and Cousin are playing a game where they pick up colored sticks. Hakeem currently has 20 points and likes to pick up the orange sticks, earning 8 points every turn. His cousin just lost all her points in the previous term and has a strategy to catch up that will include getting all the red ones, earning 12 points per turn. In a certain number of turns, the score will be tied. How long will that take? Okay, so we've got Hakeem and Cousin. Odd names. Okay, Hakeem, Cousin. And it looks like Hakeem has 20 and is earning 8 for each stick. I'm just going to say X for sticks. I don't like using an S because it looks too much like a 5. Anyway, his cousin has 0 points but earns $12 for each red stick. So there we go. Let's see. And of course, our scale is not the same. Looks like we're counting by tens. So we pretty much have to get the numerator to 10, to a power of 10. In the first one, we could multiply by 5 and get to a power of 10. And it looks like the turns will work out that way. So we're going to start with Hakeem. And he starts at 20. And he's got 8 over 1. He's going to earn 8 points per turn, which is the same as 40 points for 5 turns. So he's going to go up 40 points over a period of 5 turns. There it is. Very, very easy to make mistakes on these, so be careful, especially when you're in the end zone. So 12 over 1 is for the red sticks, and we want to change it to some number that's in counts by tens. So I can multiply by 5 over 5, which is 60 over 5, isn't it? So the cousin starts at 0 and goes to 60 over 5, and there they are. I think you have to get the graphs right in order to get the right answer too. And it's going to take 5 turns for them to be equal. And if I put 5 turns in for the cousin, it's 60. If I put 5 turns in for Hakeem, it's the same. So 5. And we're getting there. Sorry, it's going a little slow today. Let's see. Jayla is considering using one of 2 venues. A hotel in Dayton will cost $150 for the reservation plus $10 per person. So the hotel in Dayton costs $150 plus $10 per person. I'll just put P for person, I guess. The restaurant in the same city, a restaurant. So this is the hotel, sorry. This is the hotel and restaurant we want to compare. And 100 plus 20 per person. And we want them to see about and it's attendees or people. And it looks like we're going to start with hotel. Let's get rid of this for a second. Hotel is going to be 150, there it is, plus $10 per person. I need to change my slope, my rate of change to 10 over 1, but I can go, I'm counting by 50s on this scale for the cost. So it's 50 over 5. So it can go up 50 over 1, 2, 3, 4, 5 people. So that's $10 per attendee for the hotel. Now the restaurant starts at 100 and goes up 20 for every 1 attendee. Now 20 I can't do, but I can multiply by 5 and get 100 over 5. It's going to cost $100 for 5 people. So $100 for 1, 2, 3, 4, 5 people puts us equal. 5 attendees is going to cost the same at both. And I like putting the 5 right there just to double check it. That one, this first one is going to cost $200. The second one is going to cost $200. Looks like this may be our last one, maybe two more. Emily has just become a personal trainer and is finalizing her pricing plans. One plan is to charge $100 for the initial consultation and $80 per session. So this is going to be plan one. I'll just call it P1. 100 for the initial consultation plus $80 per session. X's are the number of sessions. It's important that you kind of at least semi-define your variables to start with. Another plan, this is going to be plan 2, is going to charge $50 for the consultation plus $90 for each session. So there's our two equations. Let's see if we can. Here's our first plan. And we have 100 plus 80 per session. 80 over 1, and it looks like I'm going to have to multiply by 5 over 5. So that is 400 over 5. So she's going to make $400 over 5 sessions. And if I go up 400, wow, that's a lot. Yep, it's going to fit just barely. I don't really see another option. So for the first plan, she's going to go up to 400. She's going to go up 400 over 5 sessions, which puts her at five sessions, gives her $500. And I'm going to test it right now just to make sure. That's 400 plus 100 makes 500. There you go. Now for the second plan, we start at 50, which is right there. And it's going to make 90 per session. And this time we're going to multiply by 5 over 5 again and get the 450 over 5. So from here, she's going to go up 450 over 5. And sure enough, we end up in the same place. And I already know that that's going to work because 5 times 90 is 450, plus the 50 makes 500. So the break-even point is at 5 sessions. One last one. 2 students in Mr. Hamilton's class, Mike and Nancy, have been assigned a workbook to complete at their own pace. They get together at Mike's house. Mike has already completed 25 pages and will continue working at 4 pages per hour. Mike has already completed 25 and he's working at 4 pages each hour. Nancy has completed 5 pages but works at 8 pages per hour. Clearly, Nancy is not as enamored with Mike as vice versa. So looks like Mike's distracted here. But luckily he has a head start. So let's see. Mike starts with 25. There's 25 pages, and he's going to earn 4 per hour. And our scale is going to have to be by 5s. So it looks like I'm going to have to take Mike's slope and multiply it by 5 over 5, which is 20 over 5. He's going to finish 20 pages in 5 hours. So 20 pages will put him at 45 after a period of 5 hours. So it looks like it's here. Good idea to double check it. It went up 20. That's 10, 20 over a period of 5 hours, sure enough. And 5:45 is the point. I like to put it in there. Nancy's just happens to be for 5. And I'm going to go ahead and just take a look at what happens. But of course, we can put the 8 over 1 and change it to, by multiplying by 5, we have 40 over 5. So she starts at 5. And she goes up 40, which puts her all the way over here. And there's their break-even point. And they are both going to finish the 45 pages, aren't they? So I hope you guys will get it and keep looking down. I got to quit doing that. And you all have a good time finishing up your word problems, graphing systems of word problems. How fun was that? So I'll see you back again sometime. Bye.